So let's dive into the fascinating world of the sailing stones phenomenon in Death Valley National Park. To fully grasp this mystery, we first need to understand the unique geological formations and climate conditions that exist in this remarkable location. Death Valley National Park, located in eastern California, is known for its extreme weather conditions and striking geological features. It holds the record for the hottest temperature ever recorded on Earth, reaching a scorching 134 degrees Fahrenheit in 1913. This arid desert landscape is characterized by its vast salt flats, sand dunes, and rugged mountains. One of the most intriguing places within the park is the Racetrack Playa, a dry lake bed that spans nearly 3 square miles. The surface of the Racetrack Playa is a flat, cracked expanse of mud that dries out under the intense desert sun. It is here, on this desolate and barren landscape, that the sandstones have been found to mysteriously move across the surface, leaving long, winding tracks in their wake. The sailing stones themselves are large rocks, some weighing as much as 700 pounds, which have somehow traveled vast distances across the dry lake bed, seemingly under their power. The tracks they leave behind can stretch for hundreds of meters and sometimes make sharp turns, adding to the enigma of their movement. The unique combination of geological formations and climate conditions in Death Valley has created the perfect environment for the sailing stones phenomenon to occur. The arid climate causes the Racetrack Playa to dry out, creating a smooth, flat surface on which the stones can glide. Additionally, the surrounding mountains help to channel strong winds across the playa, which play a crucial role in the movement of the stones. Now that we have a better understanding of the unique environment of Death Valley National Park and the Racetrack Playa, let's delve into the various hypotheses that have been proposed over the years to explain this captivating mystery. Now that we've set the stage in Death Valley National Park, let's dive into the various hypotheses that have been proposed over the years to explain the mysterious movement of the sailing stones. For decades, scientists and curious minds alike have been captivated by this enigma, and many theories have been put forth in an attempt to solve the puzzle. One of the earliest and most straightforward theories suggested that strong winds were responsible for the movement of the stones. It was believed that gusts of wind, possibly amplified by the surrounding mountains, could be powerful enough to push the rocks across the smooth surface of the Racetrack Playa. However, this theory was later deemed insufficient, as the wind speeds required to move some of the heavier stones would be quite extraordinary. Another hypothesis proposed that water played a significant role in the movement of the sailing stones. According to this theory, rainwater could accumulate on the Racetrack Playa, creating a thin layer of water that would reduce friction between the stones and the ground. As a result, even moderate winds could potentially move the rocks. While water does occasionally accumulate in the area, this theory alone could not fully explain the phenomenon. Some researchers then began to consider the possibility of a combination of wind, water, and ice in the movement of the stones. They suggested that during the rare occasions when the playa is covered with water, freezing temperatures could form thin sheets of ice around the stones. The wind would then push the ice-encased stones across the lake bed, leaving the distinctive tracks behind. Yet another theory proposed that magnetic forces could be responsible for the mysterious movements. This hypothesis suggested that the stones contained high amounts of iron, which could interact with the Earth's magnetic field and cause the rocks to move. However, this idea was later dismissed, as the stones were found to be made of various non-magnetic materials. These are just a few of the many hypotheses that have been explored in the quest to understand the sailing stones phenomenon. As we'll see in the next section, it wasn't until groundbreaking research and experiments were conducted that the true mechanism behind the movement of the stones was ultimately revealed. Let's now delve into the groundbreaking research and experiments that finally shed light on the true mechanism behind the sailing stones' mysterious movement. For many years, scientists struggled to pinpoint the exact forces responsible for this peculiar phenomenon, but a series of innovative studies would ultimately provide the answers they were seeking. In 2011, a team of researchers led by Dr. Richard Norris from the Scripps Institution of Oceanography embarked on a mission to solve the sailing stones mystery once and for all. They initiated a project called the Slithering Stones Research Initiative, which involved placing GPS tracking devices on several stones and setting up time-lapse cameras around the racetrack playa. Over the course of 2 years, the researchers closely monitored the movements of the stones and the environmental conditions on the playa. Their hard work and patience paid off when, in December 2013, they finally captured the stones in motion on their time-lapse cameras. The footage revealed that the key to the sailing stones movement was indeed a combination of water, thin sheets of ice, and wind. When the racetrack playa experienced a rare rain event, it would accumulate a thin layer of water. As temperatures dropped overnight, this water would freeze, forming sheets of ice around the stones. When the wind blew across the playa, it would push the ice-encased stones, causing them to glide across the surface and leave their distinctive tracks behind. This discovery was a significant breakthrough in solving the sailing stones mystery. The researchers' use of GPS tracking and time-lapse photography allowed them to observe the phenomenon in action and provided definitive evidence of the forces at work. It proved that the combination of wind, water, and ice was responsible for the seemingly impossible movement of these massive stones across the desert landscape. With this newfound understanding, we can now focus on the role of thin sheets of ice and water in combination with wind and how they work together to create this captivating geological marvel. Now that we've examined the groundbreaking research that revealed the true mechanism behind the sailing stones movement, let's dive deeper into the role of thin sheets of ice, water, and wind in this fascinating phenomenon. As we've learned, the sailing stones movement occurs when a rare combination of environmental factors come together. When the racetrack playa experiences rainfall, a thin layer of water accumulates on the dry lake bed surface. This water then freezes overnight as temperatures drop, forming thin sheets of ice around the stones. These ice sheets play a crucial role in the sailing stones phenomenon, as they essentially encase the stones and act as a floating platform. When the wind starts to blow across the playa, it pushes against the ice sheets, causing them to move. As the ice sheets glide across the surface, they carry the encased stones with them. Since the layer of water beneath the ice reduces friction between the ice and the ground, even relatively moderate winds can generate enough force to move the stones. As the day progresses, the sun's heat causes the thin ice sheets to break apart, releasing the stones. The stones then continue to glide across the wet surface, leaving their distinctive tracks behind. Once the water evaporates and the playa dries out, the tracks remain etched into the mud until the next rain event. This intricate interplay of ice, water, and wind is what makes the sailing stones phenomenon so captivating and mysterious. The perfect combination of these factors is required to set the stones in motion, and it is this delicate balance that has puzzled scientists and enthusiasts alike for decades. With a better understanding of the forces behind the sailing stones, we can now explore the broader implications of this phenomenon and its potential impact on the study of other geological mysteries. As we wrap up our exploration of the sailing stones phenomenon in Death Valley National Park, it's essential to consider the broader implications of understanding this captivating mystery. Not only does this knowledge enrich our appreciation of the natural world, but it also has the potential to impact the study of other geological mysteries and highlights the importance of interdisciplinary research in solving complex scientific problems. First and foremost, unraveling the mystery of the sailing stones serves as a reminder of the incredible forces at play in our natural world. By understanding the unique interplay of ice, water, and wind that causes the stones to move, we gain insight into the complex processes that shape our planet's landscapes. This knowledge can help inform our understanding of similar phenomena in other regions, or even on other planets, where similar conditions might exist. Additionally, the study of the sailing stones demonstrates the value of interdisciplinary research in solving complex scientific problems. Researchers from various fields, including geology, meteorology, and physics, collaborated to piece together the puzzle of the sailing stones. This collaborative approach allowed for a more comprehensive understanding of the phenomenon. ultimately leading to the groundbreaking discovery of the true mechanism behind the stone's movement. By embracing interdisciplinary collaboration, scientists can tackle complex problems more effectively and make significant advancements in our understanding of the natural world. Finally, understanding the sailing stones phenomenon also underscores the importance of preserving our planet's unique and fragile environments. Death Valley National Park, with its extreme climate and striking geological features, is a testament to the incredible diversity of our planet. By studying and appreciating these natural wonders, we are reminded of the need to protect and conserve these environments for future generations to learn from and enjoy. In conclusion, the sailing stones of Death Valley serve as a captivating example of the mysteries that our planet has to offer. By understanding the forces behind this phenomenon, we not only gain valuable insight into the natural world, but also open the door to further exploration of other geological mysteries and the importance of interdisciplinary research in our quest for knowledge.